All right, class. Welcome. This is Mr. Hart. I am making this podcast for the first week in Earth Science. We are talking about stars, galaxies, and the universe. So, first of all, we went over how big we are compared to other objects in the universe. And so we went to this website right here. And if you are watching this video, I would highly recommend going to it. It's a pretty cool simulation showing how big we are compared to the universe, to atoms, and really gives us a good scale of where we are. But after that, we talked about the universe, what it is, what it's made out of, and when we think about the universe, really it consists of everything. Okay, time, space, matter, energy, they're all within the universe. It consists of everything. Okay, the universe is 14 billion years old. I would memorize that if I were you. It is also 93 billion light years across, and is 10 to the 80 atoms in the observable universe. Okay, so this place is ginormous. Okay, there are 10 to the 80 atoms. That is a giant number. That's a 1 with 80 zeros on the end of it. Okay, so this is a big place, the universe. So there's nothing that we know of outside of the universe at this point. Okay, the universe is everything, and it is ginormous. Okay, so one of the first questions we want to answer is the universe expanding or shrinking? Okay, this was a big question that came up back in the early 1900s. Okay, after Einstein proposed his theory on relativity, it showed that the universe should be expanding. Okay, so a man by the name of Edwin Hubble wanted to prove this. Okay, he wanted to see if the universe was shrinking or expanding. Okay, and he made up a way to do it utilizing what's known as the Doppler shift. Okay, so if you haven't heard the Doppler shift before, it's what happens when a wave comes towards us and we hear it, but it sounds different than what we would usually hear or what we would usually see. So a Doppler shift is a change in the perceived wave frequency because of a movement from the observer. Okay, so there's also this simulation online. Again, if you want to go to this address or just search Doppler shift simulation. Okay, it kind of shows that when we move towards objects, the wave starts to compress or contract based on which direction we're heading. Okay, so Doppler shift comes from this changes. Okay, so what Edwin Hubble discovered is that he could look at stars and he could see if there was a Doppler shift. And what he saw was most of them were red shifted, which means the light appears more red in color because the star is moving away from it. Okay, so if the star is moving away, these are where we would usually see the different types of light from a star. Okay, these black lines, but you notice instead we got these lines. Okay, they're a little bit higher, they're a little bit more towards the red side. Okay, so they're called red shifted. Okay, so that means that the stars and galaxies he was observing, were moving away from him, or red shifted. Okay, so what does that mean? If everything is moving red shifted, then the universe must be expanding. Okay, so Edwin Hubble was the first to discover this, that all these galaxies, all these stars were moving away from him, so the universe must have been expanding. Okay, so this picture kind of illustrates this idea. Okay, that let's say we're right here. Here's our galaxies, these 4 little galaxies right here. As time moves on, okay, the space between the galaxies is going to get further and further apart. Okay, so it doesn't mean the galaxies themselves necessarily are getting bigger, but the space between them is expanding. Okay, they're getting farther and farther apart. So this was huge. Okay, that Edwin Hubble's able to verify Einstein's ideas that the universe must be expanding. Okay, but there's another part of this that comes from this. Okay, if the universe is expanding and expanding and expanding, if we look at the opposite direction, at one time it must have been smaller, and then smaller, and then smaller. Okay, and so we are able to keep doing that both visually and mathematically and saying, hey, the universe must have been much smaller. So how did it all start? When did it start expanding? How small was it? Okay, so that comes to the theory of the Big Bang. Okay, so if you think about the theory of the Big Bang is stating that at one time, all the time, energy, space and matter in the universe was shrunk down to a single point. Okay, and as space expanded, the matter, energy, and time naturally filled it. Okay, as it expanded. So to visually look at it, it would look like a giant explosion, right? As space expands, the matter would go in to fill the space. Okay, so that's why we call it the Big Bang. Okay, so here's some important points of the Big Bang. Okay, so at one time, all the matter and energy was concentrated in one area. Then there's this huge explosion or expansion, as you can think of it. Okay, so atomic particles were then formed, protons, electrons, neutrons. Once there was more space, they started forming atoms, okay, like hydrogen and helium. Then some heavier elements like sulfur and iron, silicon and iron. And then billions of years later, these atoms became planets and stars, which we see today. And then the universe is still expanding. Okay, so these are the effects of the Big Bang. And this is what the theory states. Okay, so we watched a video about the timeline of the Big Bang. You can look one up online if you want. Okay, but this is the timeline I want you to remember. Okay, so here we are at the start. Big Bang happens. Okay, within a millisecond, within a microsecond, the universe has formed its shape, has determined how it's going to expand, right? The space expands, the matter naturally fills how it's going to be, and this shaping is going to affect the rest of the universe for the rest of known time, right? Okay, then 3 seconds later, basic elements form, like hydrogen, helium. Okay, then 10,000 years later, we start to get our first nuclear fusion reactions, which start to emit light. Okay, then 300,000 years later, we start to get matter domination. The first things that start to look like stars and planets start to form. And then finally, 300 million years later, we finally get the stars and galaxies and planets that we are used to, and we start to see, the galaxies and things that we are accustomed to in the universe. Okay, so this is the timeline I would be familiar with. Okay, about the Big Bang. Then we talked about what is dark matter. Okay, and we also talked about we were also assigned homework 2.1. Okay, so going back to dark matter, we watched this video by Physics Girl is her name, or what she goes by, and it's available at this website if you want to look at it. It's also uploaded to my site, hardscience.com. Okay, and she gives a really good overview of what dark matter is and why it's there and how we know it's there. But basically, to think of dark matter, it is just the matter that doesn't interact with light, but we know it's there because of the way that it's bending objects. Okay, so for example, here's light from a star. Here's the Earth. We can see the light from this star because of this bending, right? So this galaxy must have a lot of mass in order to bend the light. But what we found is when we measured something like this galaxy, it has a lot less than we would expect. So we assume that there must be some type of matter in this galaxy that's making up most of the mass that we can't see because it doesn't interact with light. Okay, that's dark matter. Then we also talked about dark energy, which explains why the universe is expanding faster and faster instead of getting closer and closer together. Okay. So here's a simple chart that I would memorize to help you understand the difference. Okay, so there's baryonic matter, or the normal matter, which we're used to. Okay, it makes up 5% of the universe, and it interacts with light, and the direction of gravity is towards the object. Okay. Then there's dark matter. It makes up 69% of the known... Oh, oops, that's a typo. Sorry. This makes up 26%. And this makes up 69. Sorry about that. Okay. So, dark matter makes up 26% of the known universe. It does not interact with light, and its gravity is towards us. Okay, towards the object. And then there's dark energy, which makes up 69% of the universe, does not interact with light, and moves away from the object. Okay. This explains why the universe is expanding faster and faster, because if 69% of the universe is made of dark energy, then a lot of stuff wants to push away from itself, right? It wants to make the universe expand. Okay, so that's the difference between dark matter, dark energy. Okay, then we watched a documentary called Beyond the Big Bang. It talks about Edwin Hubble. It talks about these two guys named Gamow and Hoyle. Okay, they were proponents of the Big Bang. Gamow was a proponent of the Big Bang, and Hoyle was a proponent of the steady state theory. Okay, he proposed the steady state theory. So here's kind of a difference between the two. Okay, we accept the Big Bang theory today, not the steady state. But the Big Bang theory says the universe is expanding. It started as a single point, and the universe is dynamic and changing. Whereas the steady state theory says that the universe is a constant size, has no beginning or end, and that it is static and unchanging. Okay, but eventually, the Big Bang comes out top, and the steady state theory is disproven after Penzias and Wilson. Two Bell Lab workers were able to find the background radiation from the remnants of the Big Bang. Okay, and so here are some points to remember about the history from the Big Bang. Okay, there's a man by the name of Father Lemaitre who proposed the expansion of the universe and the Big Bang theory. There was Edwin Hubble who verified the expansion. There was Hoyle who proposed steady state theory. There was Gamow who was a proponent of the Big Bang. And there's Penzias and Wilson who discovered background radiation to verify the Big Bang theory. All right, so that's most of what we covered in week 1 of Earth Science. Hopefully this was a good review for you. And let me know if you have any questions, and thank you for watching.